Hey guys, I'm just going to show you a little video. We are going to go over our lab, which is a candy lab. Unfortunately, we do have to be online for this because it would have been pretty sweet to eat some candy and learn about the tectonic plates and just how the Earth is put together. And so, basically, in this lab, we're going to get to this model right here. I do want you to take a second. This is our endpoint. This is a model of the Earth. If you took the 3D sphere that is Earth, cut it in half, and then showed it, this is what we're looking at. And so there's a couple different parts that go into this model, and I just want you to think about that and what it could possibly be for a second. Maybe take a moment to pause this video in order to do this and make this model. It really is not hard, and so we're just going to use some Skittles, and we're going to use well, there's the other end of the Oreo and some chocolate syrup as well. So let's build this model, and then let's talk about how the heck it represents the Earth. All right. All right, guys, as you can see, we are going to be using all of these resources to make this model. And so we're going to wind up opening this Oreo. If you do have the materials at home, you can totally build one of these and go along. It does taste well because I did wind up eating this after I finished making it. But basically, we just open up the Oreo, we add a little bit of the chocolate syrup in the middle, and then we throw the Skittle in the middle. And so I want you to think about what is at the center of the Earth. Okay, what does the Skittle represent? All right, because that is the model that we're looking at here. And so just think about that for a second. And then what possibly could the syrup represent? And then what possibly could the cream of the Oreo represent? And then the Oreo itself on the outside, what would that represent? All right, because we're looking at the Earth as if we cut it literally in half. The complete Earth, cut it in half. What would be at all those spots? So just give it one sec, think about it. We'll come back to the answer here in a second. All right, guys. So now that you've had a chance to think about our model that we've just created, I'm going to kind of spoil it for you on what exactly each part stands for. So going from the outside in, if we're talking about the actual Oreo cookie part on the outside, that dark spot, it's a really thin layer, and it's the layer that we live on. Okay, this is where the surface of the Earth is, and this is going to be called the crust of the Earth. Okay, the crust. And then once we get into the inner layer, okay, part of the crust would be the lithosphere as well. And this is the tectonic plates are part of this as well. What the tectonic plates rest on, and what is not completely solid but is mainly molten rock and allows those tectonic plates to slide around, okay, is going to be the white cream part of the Oreo, which is going to be our mantle. Okay, also the asthenosphere. Okay, now once we go super deep into the Earth, about the size of the moon itself, okay, is the Earth's core. Now this is the Skittle part. Okay, that is the core of the Earth. It is solid. All right, it is solid and it is made up of iron. Okay, the reason that the core is made up of iron is because the heaviest materials are going to sink to the center of the Earth, and iron is a very dense material, and so it's going to go to the center of the Earth. We create this gigantic iron ball, all right, and because the Earth is still active, and because that active with like volcanic activity, it hasn't completely cooled down. That iron ball, the friction that it creates with the outer core, okay, is going to basically wind up having molten iron, which means it's going to be melted, and that's going to be the chocolate syrup around the core. Now, this melted iron is going to be spinning around and moving pretty quickly, creating a lot of heat, and also what supports the magnetic field that surrounds the planet. This is super important for protecting us against certain rays, especially dangerous ones that are emitted from space and specifically from the sun. So this is a really important part. And so again, the Skittle is the core of the Earth, whereas the chocolate syrup part is going to be that outer core, which is not solid. It's actually liquid iron, where then we get to the molten mantle, okay, where it's just melted rock, which is what the tectonic plates are going to slide on and the tectonic plates on the very top of that is going to be the crust in which we live on. So that's going to be our model. Hopefully you can visualize that kind of in your head and what's going on. All right, so as we look at this Milky Way, we're going to crack it and slightly pull it apart. All right, and I do want you to think about, especially now as we turn it to the side, I'll pause the video, what parts of the Earth are we going to imagine are part of the Milky Way? What exactly is going on? And how this model represents different plate boundaries and how they're going to interact. So take a moment to think about that, and let's keep on going. So our Milky Way, we are going to have that chocolate outside part is going to actually be the crust, whereas the caramel middle is going to be our lithosphere that the crust is going to kind of ride on, whereas underneath that is going to be our mantle, where the actual Milky Way thicker, sturdier chocolate is going to be. And so that lithosphere allows the chocolate on top of the crust to move around and collide with one another. So let's see what happens when we slide it together. This would be an example of a continental convergent plate. Okay, you can see how, and I just want to wait 1 second here, you can see how a mountain is forming. Okay, but what I really want to point out, you see how the mountain is forming up high above ground, but it's also getting really thick below ground. One thing that I want you guys to remember is that mountains are going to be just as thick on top and above ground as they are below what you can't see. It's just mountains are very thick parts of the Earth's crust. This is the last one we're going to look at. I honestly don't think this is the best example in the world of showing a transform plate boundary, but this is what would happen in California, like the San Andreas Fault, where there's a lot of earthquakes that are created. But as these plates, as they're sliding back and forth, what is going to happen is this happens very slowly until there's a movement. Okay, so it's nothing's happening, and then all of a sudden, boom, a big shift. That big shift is called an earthquake because it's going to send a rippling effect into the plates. And so this is trying to kind of show that that sliding motion and what I want you to remember for transform plates. But you can see how a quick movement can create a huge shift in the